Only when this fish from 310 million years ago crawled ashore did it truly understand the perils lurking on land. Let's journey back 500 million years. Back then, the Earth's surface bore no resemblance to the vibrant world we know. It was utter desolation, a wasteland, where truly not a single blade of grass could be found. As desolate as the moon's surface, it's hard to fathom how any life could endure such hostility. Yet life always finds a way. While the land remained forbidding, the oceans teemed with a different story. Life had already flourished there for over 1 billion years. Then came a wondrous organism, lichen. Neither plant nor animal, a true marvel. It boldly took the first steps, challenging the harsh land. Seemingly insignificant, lichen is an incredible partnership, a wondrous combination of fungi and algae, utterly reliant on each other. They didn't just tenaciously survive. They slowly broke down bare rock, forming the very first soil, creating the conditions for plants to finally conquer the land. Their contribution was truly indispensable. Once that first precious soil existed, miniature pioneers like moss began to appear. With leaves just a single cell thick, they couldn't grow tall, forced to spread outwards across the surface. Yet, they multiplied even faster than the lichen. Before long, a vibrant green carpet unfurled across the land, ruling this world for the next 40 million years. But fortunes change, as they always do. A green revolution was brewing, destined to utterly transform the face of the land. A revolutionary new substance called lignin emerged. It fortified plant cell walls, like giving them armor, allowing them to grow taller, bigger, and much, much stronger. They began to compete fiercely, stretching ever upwards to capture the sunlight. Some plants grew incredibly tall. Today's mighty redwoods are among their descendants. By 345 million years ago, the animal kingdom too began to stir restlessly. The first animals to venture onto land were the arthropods. Relatives of the ancient trilobites, they possessed a tough exoskeleton. This exoskeleton, their armor in the water, proved vital on land. It supported their bodies, prevented deadly dehydration, and at crucial moments, could even be used for breathing. Back then, oxygen levels were 60% higher than today, allowing some arthropods to grow to truly enormous sizes. Like Arthropleura, the largest in Earth's history, over 5 meters long and more than half a meter wide. They had virtually no natural enemies. Every day besides foraging, they were busy finding mates to ensure the next generation. But for Arthropleura, finding a partner was no easy task. Lacking sight, they could only rely on touch to perceive their world. In the vast, sprawling fern forests, finding a female was like searching for a needle in a haystack. Fortunately, females ready to mate left behind a scent trail, guiding the males. After much effort, he finally finds her. Now, the challenge is to win her acceptance. The male first robs his armored plates, creating a unique love song. The female, perhaps seeing his determined effort, finally accepts his courtship. But with such strange bodies, successful mating requires incredible coordination and cooperation. Around 300 million years ago, dragonflies first appeared in the ancient swamps. These flying creatures are paragons of the art of flight. Their 4 wings can be controlled independently, allowing each dragonfly to fly and turn with breathtaking freedom. Instant acceleration makes them effortlessly adept. Their agility is unparalleled, capable of rapid accelerations that even fighter jets cannot easily surpass. You could say their flight technology is invincible. Tested by 100 million years of time, it remains remarkably unchanged even now. However, in these same prehistoric swamps, another group of creatures was quietly undergoing a massive transformation. Underwater, the vertebrates were constantly evolving. A completely new kind of fish was quietly emerging. They were the lobe-finned fish. Some had already evolved into massive predators. In this fish-eat-fish world, smaller fish desperately sought refuge in the shallows. The unique structure of their lobe fins offered significant advantages, helping them swim with greater stability. Their movements agile, their muscles powerful. Unlike the fins of ordinary fish, lobe fins were more than just swimming tools. They could even support their body weight, helping them gradually crawl from the water onto land. However, the greatest evolutionary leap for these fish lay in how they breathed. They didn't rely solely on gills, but used primitive lungs to inhale air. It was precisely these evolutionary steps that allowed vertebrates to leave the water and set foot on land, embarking on competition with the denizens of this new world. However, for these lobe-finned fish, it was perhaps a bit late. Other animals had already gotten there first. Like this 3-meter-long temnospondyl, it had already developed 4 legs, beginning the long evolution from fin to limb. And once complete, they could adapt to life on land, ushering in the great age of amphibians. 300 million years ago, Earth welcomed the start of the Carboniferous period. As continents merged, the supercontinent Pangaea was born, marking a new era. Yet, with the drying of the land, the vast swamps gradually disappeared. Lack of water plunged most amphibians into dire straits. But in this environment of dramatic change, some amphibians evolved. An astonishing new adaptation. Their eggshells changed, evolving a tough protective membrane, providing a safe haven for the embryo's development. In this enclosed environment, the young could develop smoothly, avoiding the danger of dehydration. Precisely because of this evolution, they no longer depended on water for reproduction. successfully bringing forth offspring on dry land. They were the amniotes. This evolution paved the way for later mammals and reptiles, even bird and dinosaurs, opening an entirely new chapter of life. 60 million years after the evolution of the egg, 252 million years ago, with the appearance of amniotes, two new dynasties rapidly arose on Pangaea. Among these rising new species was a primitive reptile clad in heavy protective armor. Apatosaurus became one of Earth's earliest giant herbivores. They weighed over a ton. These animals, through the evolution of the egg, could survive and reproduce in arid environments. And another bloodline evolved. They were the ancestors of mammals like Lystrosaurus. Although Lystrosaurus couldn't rival Scotosaurus, its relative the Gorgonopsid certainly could. Gorgonopsids reached 3 meters long, weighing over 300 kilograms. Relying on a powerful sense of smell, they could track prey. But breaking through the tough outer shell wasn't easy. Fortunately, the Gorgonopsid possessed sharp, blade-like teeth that could easily tear through defenses. Despite this, it still had to approach its prey cautiously, precisely selecting the moment and target, silently launching its predatory strike. The competition between mammal ancestors and reptiles had already quietly begun on this continent. For hundreds of millions of years, life on Earth had constantly evolved and flourished. However, such prosperity would not last forever. In the north of Pangaea, a devastating catastrophe was brewing. Immense energy, buried deep within the Earth's crust, accumulated over countless ages, grew restless. The underground world of magma surged violently, searching for any crack to erupt. Searing magma advanced quietly towards the surface. Once the Permian eruptions began, they could not be stopped. The scale of this eruption was incredibly violent, unprecedented. It lasted for a staggering 100 years, bringing unprecedented destruction to Earth. Millions of square kilometers of land were engulfed by lava. The catastrophe had only just begun. The eruption brought not only scorching lava, but also something far deadlier than lava: toxic gases. As these gases combined with water, intense acid rain swept across the land, destroying all plant and animal life. Without the support of plant roots, the soil was washed away, the entire ecosystem collapsing. At the same time, the air filled with an invisible killer, carbon dioxide. The carbon dioxide released by the eruptions was 6 times the amount in today's atmosphere. This caused global temperatures to rise by 10 degrees. Climate disasters followed one after another. The greenhouse effect intensified. Animals had nowhere to hide. The oceans became the most devastated areas. Seawater temperatures rose, acidification intensified, compounded by a sharp drop in oxygen levels. The oceans that once nurtured life now became barren lands of death. Earth's third mass extinction event led to the disappearance of 90% of all species. Despite this, some life miraculously survived. They would pave the way for a new era, opening Earth's next brilliant chapter.